There we go. I think I fixed it. Do you guys have audio now?
There we go.
I'm so sorry. I'm making all these changes to Canvas because I'm not to Canvas to Zoom just to avoid the probability of us being Zoom bombed. They keep warning us about that. And I had an experience with that. It wasn't that bad. It was just annoying. They were just being disruptive. I've heard of professors who've had like inappropriate things written on their chats or racial slurs being said and stuff like that. So I don't want us to go through that. All right. So I'm sorry, you guys didn't hear anything. So I have three things to go over today. We're gonna do our lecture. I want to go over our schedule and go over how to enroll into my math lab. So I made a mistake. I don't know why I wrote 410. I meant to write 210. I'll blame it on the fact that it's a cloudy day. I'm tired. All right, so let's go ahead and continue with today's lecture. We're going to go over 4.3 and 4.4. So let me go ahead and share my screen. And just so you guys know, all of you, when you first chime in, are muted. And if you ever want to ask a question, please do at any time. Feel free to drop your question. Just make sure to unmute yourself. And that's all you need to do. All right, so let me go ahead and share my screen. Okay, so we're going to continue today with section 4.3. Before we go into 4.3, let's remember some important pieces about a basic sine and cosine graph, which is what we learned in section 4.2. All right, so I'm going to draw on the margin, but I recommend that you go ahead and why don't you take out a separate sheet of paper and write this on your sheet of paper. I think it'll be helpful just to have it handy, just so you have something to refer to for the remainder of the section, just because it heavily relies on knowing those basics and just having it handy. All right, so just to recall, when we're graphing a sine function, so let's say f of x is equal to sine of x. How does that look like? Well, we know it looks like a little wave, right? But this little wave function is going to start differently than that of cosine. So we want our four regions, 1, 2, 3, 4. That will be part of our period. For sine, we start at 0, and then we go up 1, go back to that median point, go down 1, and then back to the median point. And we connect them in a wave-like fashion to make our sine graph. Now, I did not put anything, right? But we know that our maximum value that we reach is 1. That lowermost point that we reach is -1. The period of a sine function is 2 pi. So this middle one will be pi. That'd be pi over 2. And then 3 pi over 2. So those are some sine functions. One of the most important things I want you to keep in mind is where it starts. It starts at 0, right? So that's something that should be super important that helps us identify that it's sine versus cosine. And another thing I want you to keep in mind is our next point that we work with is up 1. It's not going down, right? It's going up 1. So this is an idea to let us know that it's a sine function without a negative in the beginning, without being reflected over the x-axis. So this should be our next point. All right. Now moving forward, we're going to do the same thing with cosine. So a general cosine function, say f of x is equal to cosine of x. Same idea, I want to graph it. So we're going to do our chart. And I want to point out some important features of a cosine function. So it's going to be split into 4 parts. 1, 2, 3, 4. And we're going to plot these points. What makes a cosine function different than a sine is that it starts above, goes down, works its way back down to the bottom, middle point, and back up. This gives us one period of a cosine function. Now let's label these important points that we can outline for our cosine function. One of them is we don't start at 0, we start above the highest point, which if it doesn't have any shifts should be 1. And the length of a period is 2 pi. So the middle point will be pi, half of that will be pi over 2, and that third one would be 3 pi over 2. And also that lowest most point is a -1. So important features that we need to keep in mind for a cosine function is that we start not at 0, right? And the reason I say it's not at 0 instead of 1 is because if it's reflected over the negative axis, then I could potentially start here. But that's something we would have to keep an eye out for. And also, that's what makes it important, is that we start at the highest point and then work our way, right? Okay, so those are some important features of sine and cosine. Like I said, I recommend you write on a separate sheet of paper, maybe a post-it, just so that you have what the parent basic function looks like. All right, let's continue with is the function. Based on certain information of the graph, amplitude, y-intercept, reflexivity, and period, can we determine the function that makes that graph? And can we write the function as either? So we have f of x equals a sine of bx, or a equals cosine of bx. So just remember what a and b do. So a is our amplitude. That refers as to how far high and up our function goes. Now, assuming that we do not have a vertical shift, it's our highest value, right? But really, it's a measurement from the middlemost value to the, I guess you can say highest. That would be the amplitude. B is the frequency of a period, meaning how long is your period, right? And we can find that with the formula of 2 pi divided by your period. That gives us our frequency. So there are 2 things that we learned in our last section. Let's continue with our text. The value of A. We must recognize whether the graph is a sine or cosine function based on its y-intercept. If the y-intercept is 0, then the graph is a sine function. That makes sense, because looking at our beginning part, we see, hey, we start at 0, and we said that was a very important thing. Next, the y-intercept is either at a maximum or minimum, then the graph is a cosine. We pointed that out as well. We saw how in cosine, it doesn't start at 0. It starts maybe at 1. It can also start at -1 if it's reflected over the negative. I'm sorry, over the x-axis if it has a negative in front. Moving forward. The value A indicates 2 bits of information. The amplitude, the height of the graph above the axis, and 2, where the graph is reflected or not. The graph is reflected, A is then negative. The value of B. The most challenging piece of this puzzle is to identify the value of B. The coefficient x, B is the frequency of the function, and it is found using the formula B is equal to 2 pi divided by a period. This formula for b comes directly from the formula of a period. Period is equal to pi divided by b. In class example 1, develop the formula b is equal to pi divided by your period. I manipulate the formula for period. So let's go ahead and do this example. For example, if the period is 2 pi over 3, then b is equal to 2 pi, and then we have here that 2 pi over 3, which is a period. And remember how you divide fractions? You go ahead and if you have 2 pi divided by 2 pi over 3, then you multiply it by the reciprocal. So we have 2 pi times 3 over 2 pi. Our 2 pi and our 2 pi divide to make 1, so we're left with 3. This means the argument of our function is 3x. This is true where the function is sine or cosine. So let's go ahead with example 2. Given the period of the value of the frequency, b. Okay, so let's find the value of the frequency. So we're told the period, all we have to do is make that the divisor of 2 pi, meaning all I have to do is rewrite this with a 2 pi on top and simplify, right? That would give us our answer. So for the first one, I have 2 pi divided by 4 pi. All right, my pi's divide out, and I'm left with 2 over 4, which is 1/2. Okay, so for A, I will have 1/2 at x, right? For B, I have 3 pi. So I write 2 pi above, 2 pi divided by 3 pi, my pi's divide out. I'm left with 2 over 3. So in my argument, I'm going to have sine of 2 over 3x or cosine of 2 over 3x. For C, I have 2 pi divided by 2 pi over 3. We work this out, we change it, we keep change flip. So our pi's cancel, our 2's cancel, we're left with 3. So we're gonna have sine of 3x or cosine of 3x. All right, moving forward. Let's do the you try it. Let's go ahead and let's do A and D. Let's only do those because I won't have enough space for B and C too. All right, so remember, you're using the formula where your where your B is equal to 2 pi divided by your period. So I want to find that B, we're going to use as sine of bx or cosine of bx, whatever story we're given. Okay, so let's work this out. So we have 2 pi, and I'm working with 6x, so I divide by, 6 pi. I divide by 6 pi. Let's work this out. So my pi's divide out, and I'm left with 2 over 6, which is 1/3. Go ahead and give D a try. Okay, so this right here is going to be what we divide by, that 3 pi over 8, so that we have 2 pi divided by what we have there, 3 pi over 8. So we're forced to rewrite this to be 2 pi times, we flip it, 8 over 3 pi, and then we work it out. So I can cancel the 2 and 3, but I can for sure divide that pi. So we're left with 2 times 8 over 1, so it's 16. Oh, I forgot that 3. That 3 didn't go anywhere, right? So that's not 16. So we have 3 on the bottom. So we have 3. So we have 2 times 8, 16 over 3 as our result. Moving forward with putting it all together. As stated earlier, the function of the graph will either be a sine function or a cosine function. This means what must identify 1, the function, is it sine or cosine? And we know this, I'll write a little hint. We know this if it starts, it starts at 0 or not. So 0 being sine, not being cosine. 2, where the function is reflected or not. A is negative or is it positive? 3, the amplitude A. So how far high our wave reaches, that would let us know our amplitude. 4, the period. Remember, that's our 2 pi divided by your period. And 5, the frequency B, which is the answer we get from that. So let's go ahead and do example 3. Given the graph, identify the function. Okay, so all we know is where it starts. That's a very important feature. And I know the length of a period. Awesome. That's really all I need. So our first rule is to determine if it's a sine or cosine function. Remember, that's basically, does it start at 0 or not? And we see that it doesn't start at 0. Because it doesn't start at 0, we know by default, this is going to be cosine. But I want to find cosine of what? And also, I want to find, do I have an amplitude? Is it something other than 1? Meaning, is my highest point 1 or something else? If it's something else, whatever that number is, that's what I want to write for A. And also, is there some type of reflection? So there's so many things to consider. But let's take it piece by piece. So that was 1. We found its cosine. So right here, the function is cosine. 2, it is not reflected, A is positive. If it were reflected, then my graph would begin down here and go this way. That would let us know it's reflected. 3, the amplitude is 2, so A is 2, right? We see this 2 right here. This lets us know our amplitude. 4, the period is 5 pi over 2. 5, I need to figure out B. So I take 2 pi divided by 5 pi over 2. And we see the work, our pi's divide out, we're left with 4 over 5. So this is our final answer. F of x is equal to 2 cosine of 4 over 5x. We took every little piece. So if you could, this would be a good thing to maybe highlight for your notes. We're going to use this whole piece of information to identify if it's a cosine or a sine function. That's really all we're doing for this entire section. All right, let's continue with part B of example 3. So our first rule that we have listed above, highlighted in yellow, is a function sine or cosine. Basically, does it start at 0 or not? So here we see that, yeah, it does start at 0. So I have a sine function. So our first answer is the function is sine. 2, where the function is reflected or not. So look at your cheat sheet that we built in the beginning of the lesson. Remember? So let's take a look back here. So it's always nice to refer back to these 2 things. So remember how it's supposed to look. Sine starts at 0 and works its way up. Cosine starts at 1 at the highest value, not the lowest value. So with that in mind, let's take a look at our function. So we know we have sine because we start at 0, but then we want to work our way up. We're not working our way up. We're working downward. So this lets us know that we're going to have, because we're working downward and not upward, it's being reflected over the x-axis. Meaning there is a negative leading the function. So we're going to have negative our amplitude sine function. So we have that in 2. It is reflected, meaning that a is negative. What number is that a? Well, let's take a look at our highest number. You see our highest number is a 3. So we have an amplitude of 3. But because it's negative, because it's reflected over, we write negative 3. 4. We see that the last piece to complete one period, one cycle, is 2 pi over 3. So we say our period is 2 pi over 3. And our last piece, 5, we take 2 pi and divide it by our period, which is 2 pi over 3. Do some algebra, we're left with 3. So we're going to write 3x in parentheses like we have here. So that is our answer. F of x is equal to negative 3 sine of 3x. And that's how every piece comes together to identify what type of function we're working with. Now, taking a look at example 3, this is your section. Are there any questions? Is there any piece that seemed off, that you didn't know where that number came from? All right, and if you're too shy to ask, I do post these Zoom lectures online, so you can always jump back. All right, moving forward. Same idea. Now let's try this on our own. So go ahead and do A. Then we'll come together as a class and do A together along with B. So I'll give you maybe a minute to do A. Go ahead and give A a try. Okay, let's go ahead and come together. So if you'd like to, maybe in our cheat sheet that we built in the beginning of the class of sine and cosine, maybe you can write this in your cheat sheet just so you have it handy as you're working out your homework. All right, so we're going to try to identify the function. First thing, is it sine, cosine? So we're going to build our function. So we have f of x is equal to something cosine of or sine of something x, right? Because I am starting at 0, I know this is going to be sine because I start at 0. So I know I have sine. Next, I know that I start at 3 and my function is moving up, not moving down. So this lets me know my amplitude. It's going to be 3, but most importantly, it's not negative, it's positive 3. So I just write in 3. Next piece of information, I see I have a period of 5 pi. So I must take that and divide it by 2 pi so I can know our amplitude. So I take 2 pi divided by 5 pi. My pi's divide out. I'm left with 2 over 5. So we have 2 over 5. And that's our answer. So our sign is f of x is, I'm sorry, our function is f of x is equal to negative 3 sine of 2 over 5x. So you gave it a try. See if you were on the right track. Do you have any questions? Make sure you bring them up. All right, let's set up for our next function. We know we're going to have f of x is equal to, we're going to have an amplitude, then sine and cosine of some argument x. Don't forget your x. Let's work this out. So we see that we start not at 0. So that lets us know we have cosine, because only sine begins at 0. That's if we have a parent function without any horizontal shifts, and we do not have horizontal shifts yet. So we know this is going to be cosine. All right. We see that we're not going from the highest point down, we're going from the lowest point. We're starting at the lower part. So this lets us know we have a negative. We have a negative beginning our function. So I have a minus. Okay, now we need the amplitude so I can attach that minus from. Our amplitude comes from that number. We have 4 over 5, or you can even think of this higher number. That lets you know that measurement from the middle point to how high up or how high low you go. So that's going to be a 4 over 5. Lastly, the one that requires a bit more work is your b. To find b, we must take our period. Where does our cycle end? Our cycle ends at 4 pi over 9. So we take 2 pi and divide by 4 pi over 9. Let's go ahead and rewrite this. So we have 2 pi times our period flipped for the reciprocal of our period. So I have 9 over 4 pi. Our pi's divide to make 1. 2 and 4 simplify to be 2. So we're left with 9 over 2. That's this number right here, 9 over 2. And that's our answer. I'm going to write it all in black so it doesn't look so funky. We have f of x is equal to negative 4 over 5 cosine of 9 over 2x. Now, hopefully, if you're not colorblind, and if you are, I can walk you through it differently. I wrote down each set of work for the problem using a color. So if you are questioning how that piece came to be, you can see the guidance on it on the graph using the matching color. So I hope that helps. Unless you're colorblind, then I'm really sorry. I should know better. Let's move forward with our text. Sometimes the period is not given to us directly, and we must do some multiplication to identify it, as shown in the next examples. So what's cool about the ones we did is it tells us exactly where a period ends, right? So that first part A, we saw that one cycle ended at 5 pi. For part B, we saw that one cycle ended at 4 pi over 9. Well, it might not tell us always where our cycle ends. If we don't know where our cycle ends, we have to do some work to figure it out. Because we want to know this number. That's the number we want, because that will let us know our period. And therefore, I just take that and divide 2 pi. Let's go ahead and see example 4 to see how to do this. Example 4, given the graph, identify the function. So let's go over our procedure. Use the 5 guidelines, 1 through 5, to develop the function. And let's go ahead and see how to work this out. So we see that our function is cosine because it doesn't start at 0. Because it starts with the minimum instead of the maximum, I know that's negative. So therefore 2 and 3, we have an amplitude of -3/2. Now 4 is what this example is all about. As shown, the quarter period is 3 pi over 16. We must multiply by 4 to find the period, right? And really, you can think about it however you like. You know, you go from 0 to our next number. We're going to add 0 plus 3 pi over 16. And then to get our next one, we know we're going to add by 3 pi over 16. And add again by 3 pi over 16. And add again by 3 pi over 16. So we're adding 3 pi over 16. We're adding that 4 times. So isn't it fair to multiply it by 4? And that's what we're doing here. We must multiply 4 to find the period. So we have 4 times 3 pi over 16 equals 3 pi over 4. So that lets us know our number right here, 3 pi over 4. Now I must continue to find b. So you use that to divide 2 pi, like we have here. We have that special number we found. We're going to divide that by 2 pi and divide 3 pi by 4. Now what we actually put into our function is b, and it ends up being 8 pi over 3. Okay, this one was really nice because we were given 1/4 of it. So to find our answer, we just multiply by 4 to find that 4th one. But what if we're not given 1/4 of it? What if we're given something other, like 3/4 of it, right? Because this is 1/4 of your graph. That's 2/4 of your graph. That's 3/4 of your graph. And that's 4/4, which is your period. So let's take a look at example 5. Given the graph, identify the function. Procedure, use your guidelines 1 through 5 to develop your function. All right, so we can do 1 through 3 pretty quick. We start at 0. Because we start at 0, we know its sign. And from 0, it goes up. From 0, it goes up. So I know it has a positive amplitude. It has a positive amplitude of 5. So I know I have f of x equals 5 sign. But what's my argument? Okay, this is what this example is all about, part 4. As shown, we have 3/4 of a period, which is 2 pi. To find the period, we just multiply by 4/3. So we go ahead and we multiply by 4/3, 2 pi, which is that 3/4 number, and we get 8 pi over 3. So this lets us know that our period, this last tick mark, is 8 pi over 3. Now I go ahead and I divide that by 2 pi, as usual. You see here, we divide that. We take 2 pi and divide that by 8 pi over 3. And our answer is 3/4. So our B is 3/4. So if it's helpful, I think it's safe to say to find the position, is it 1/4 of it, 2/4, 3/4? Well, period doesn't really matter. And multiply by the reciprocal. Since we have 3/4 of our period, like it says right here, we multiply by 4/3. Similarly, how in our last problem, we had 1/4 of our graph and we continue to multiply by 4. Okay. Go ahead and give you try 3B a try. I'll give you a minute. Okay, so I think give you a minute. Let's go ahead and do A. You did B, so we'll see if you're on the right track. All right, so A. First thing, I want to see if I begin with 0 or something else. I start with not 0, so I know that I'm going to have f of x, your amplitude, and I'm going to have cosine of some argument x. Now I start with 4. It's our highest peak, so it's going to be an amplitude of 4. And because I start with my highest point and move forward, it's going to be positive 4. So I have an amplitude of 4. Now I must determine my b, cosine of what x? All right, well, I need to find this number. That number is really important. So I think about what fraction I have. So I know this is made up of 4 parts. I have 1 part, 2/4 parts, 3/4, and lastly our 4th part, or period. So I see that I have pi over 6, which is the 1/2 mark, right? So I go ahead and take 6 pi and multiply it by 2. That's a reciprocal of 1/2. So our period is 12 pi. Okay, that doesn't really tell us anything for our function, but I can go ahead and take that 12 pi and use that to divide 2 pi by. So I have 2 pi divided by 12 pi. My pi's divide, so we're left with 2 over 12, which is 1/6. So we have 4 equals cosine of 1/6. And we can go ahead and check it, so we have this handy. You try a 3, we have f of x equals 4 cosine of 1/6. All right, do you have this for b? Let's go ahead and work it out together. So we know we're going to have f of x is equal to something, sine of, or cosine of something. All right, because I start at 0, that lets me know it's going to be sine. Okay, now remember your sine function goes from 0 and works its way up. Because we work downward, that's what we actually have, it's going to be a negative. Negative, our amplitude is 1. So I have an amplitude of -1. Or you can just write a negative. Now I need to find that last number because that will let me know my period. Okay, so we know our fraction, our graph is split up into 4. I have 1/4, 2/4, 3/4, and our last piece, 4/4, will complete one whole cycle. All right, I have at the 3/4 mark 2 pi over 3. So I'm going to take that 2 pi over 3 and multiply it by 4 over 3, which is a reciprocal of 3 over 4. All right, let's go ahead and multiply across since nothing really divides to make 1. And we're left with 2 pi times 4 over 3 times 3, which gives us 8 pi over 3. So our period is 8 pi over 3. Lastly, to get that value, we go ahead and take 2 pi and divide by that period, that 8 pi over 3. Now let's rewrite it. So I have 2 pi times the reciprocal, 3 over 8 pi.
Is it
My
not
pi
8
is
pi over 9?
over 9, thank you. 9, 9, 9. I should erase the last one. 9, thank you. All right, my pi is divided out, so we're left with 2 times 9 is 18 over 8. that can simplify, right? To just 9/4. So we have 9/4 x. Is that what we have? Yep, we have negative sign of 9/4 x. Okay, so that's the section. I like to go very slowly for graphing because I know this is something that might be totally new. Well, this whole class is probably totally new. All right, so your homework. Let me get out of here and share with you Canvas. I can find Canvas. Oh, you see my password. That's not good. Well, I guess I'll talk about it. As we continue, if you go ahead and take a look at your home screen for Canvas, I have an update schedule for you guys. So I have this here under my syllabus and stuff for trigonometry. So here is your new schedule. So for today, we're covering 4.3 and 4.4. I'm going to make 4.4, make you do it on your own. I will come back on Thursday and teach it differently. But just so you can see a different way. But I need to work up some different notes for you guys for 4.4. So I guess from here we will continue with 4.6 and 4.7 on Thursday. We also need to continue and work with our 136 portion of the course. So this week we're going to work with functions and differences of squares. I will post those files on Canvas, but you'll find them on Canvas of your 136 portion. So anything from here, check your MAT 136 Canvas shell. I don't think I have anything there, but I'll post them there and I'll send an email once they're posted. They're all available on Canvas for 136 under the title Correct, and everything is posted. It's under files. So this is kind of where we're going to work with. You have your MAT 136, which is your review portion. Your final is on the 15th. And we have a lot of things to cover, mainly factoring. Factoring is a very big thing that we have to be comfortable with to continue with, mainly chapter 6. So we're doing all this review so that you can be a pro with equations come chapter 6. Now, another question was, what are these quizzes do? So my first intention, my first thought was to make these quizzes due every week, but some of you are saying that's not enough time for you to practice. And no, I agree. Okay, I hear you. So we'll make these quizzes due on our test day. So I'm thinking of making a test available a whole weekend, so Thursday to Monday. So you have Thursday, Friday, Saturday, and Sunday to find some time to A, study, B, ask questions, and get prepared to take your exam, right? So it'll be due on March 20th. That'll be our next test. Well, you have between March 16th up to March 20th to turn it in. And that's when your quizzes are due. So all chapter 4 quizzes will be due then. And that's how we'll continue for the remainder of the semester. I have changed the due dates. So you should have seen that reflection on your due dates for your quizzes. Now, someone asked about your homework. Your homework moving forward will be on my math lab. And I am so sorry. I don't know why I thought my math lab was something common, and it's not common at all. My math lab, on your Canvas shell, on the left tab, I made it so it's the second one. You have one that reads My Lab and Mastering. You click on it, and then on the bottom of this week's module, it says information to how to log in. So once you click on My Math and Mastering on Canvas, you're gonna have to use a access code. So it might prompt you to buy a code, but we got a free one because of what's going on with COVID-19. So the publisher is being really nice with us. So they gave us a free $90 code. So that's great. So you have a code to access it. Now, to make sure that you enroll into my class and you can see our homeworks, you have to enter a course ID or enroll onto my course. So that's that Bakari and then like 4 or 5 numbers. That's the code it needs. On the bottom of this week's module, I have some information to kind of help you out through work to navigate and work with my math lab. Now, one more comment. In other schools, they have been very big about making sure that you use Canvas and my math lab using a Google browser instead of a Safari or Firefox or Internet Explorer. So if it's not working well with you, maybe it's because for me, it wasn't working with me because I was using Safari. So make sure you're using Google Chrome. And I think that's it for what I wanted to say along with today's lecture. Are there any questions? And I know I wrote 420 instead of, I'm sorry, 410 instead of 210. I don't know why I wrote 410. I meant to write 210. So that's one of the reasons I made this lecture a bit shorter, so I don't feel like I cut everyone else out from today's lecture. I'm so sorry.
Sorry, 410 verse 210, what is that a reference to?
I want to start today's lecture. Well, my plan is to always start lecture 10 minutes later. So instead of starting at 2, we'll start at 2:10. But I don't know why when I made the announcement, I said we'd start at 4:10. So I think a lot of people are waiting till 4:10 to sign into Zoom.
Gotcha. So time of day, that's what it was. Okay, thank you.
The time of the day, yeah. So I'm sorry about that, but they'll just see the recording of this. Sorry about this. One more time, Dylan? No? Okay. I thought I heard something coming from Dylan's screen. All right, well, ask me those questions. Make sure you go on to my math lab. The homework for 4.2 is posted. And the reason, another cool thing about my math lab is it gives you an instant answer. So you can see if you're on the right track or not.
Are there due dates on the homework in my math lab, or?
I don't think I said a due date, but I don't think it's the correct one. Your due date will also be the day of your test. So 4/20.
Okay, so for example, I haven't logged into this thing yet. So then supposedly the homework for 4.1 is still there and I can still access it.
Yep.
Gotcha.
That is right. You can still access your homework. I understand that we all work at different speeds and everything's really funny right now. And I don't know if you work best at home or not. So I'm giving you plenty of time to just work at your own pace. I was thinking of making everything due at the end of the semester, but I know you would shoot yourself in the foot and leave everything till late May. So I don't want that to happen. So that's why I'm making these due dates sooner. So our testing.
Not a bad idea.
I know I would leave everything till late May. All right, well, I'll see you on Thursday. I will post the 136 review so you can start working with those and ask questions. And I will update the My Math Lab homework to reflect that April 20th due date. Okay, I'll post this once it's available online. Have a nice day.
Thank you. Take care.
Take care, bye-bye.